So without any delay, I would like to start with the presentation. I hope that if there are any participants who wants to join, it would be better if you can join in the beginning. And if you have any queries during my presentation, feel free to ask. This is about my background. I'm working as assistant professor in the Department of Computer Science and Engineering at Bipin Tripathi Kumar Institute of Technology. Beyond this, I'm also heading the training placement cell at my institute. I'm the head of Central Computing Facility Center. I'm senior member of IEEE, vice chair Uttarakhand ACM Professional Chapter, and some other things are also associated. Beyond that, the privacy and security issues in social media are the research topics which I'm interested in, along with the applications of data mining, which can be applicable to, networks, VANETs, anywhere. So as of now, I'm also working on healthcare sector. So some of my publications you can find on internet. Before I proceed, I would like to see, I want to show you that what my lecture is all about. So after seeing this video, it doesn't need any sort of audio. You need to go through the concept why this video has been played. So this is a scenario of any, any city, which can be assumed by you. Like we used to come across such scenarios, like vehicles are moving around and, people are, there is no red light. By the way, there is no red light, or there is no police officer available to guide or to control the traffic. And the best part of this traffic scenario is there is no casualty. Okay, everybody is trying to find out their way of their own, applying their own intelligence, right? So big buses are coming, autos are coming, bikes are coming, although it could be dangerous. So in order to avoid all the scenarios, we are trying to make our vehicles intelligent. We are trying to make our transport system intelligent. So this is the root cause that anybody can come and it can have a severe problem to anybody. So avoid all those things. We will move on to the topic. Now I believe that you are now at least familiar with the concept that why we are going to have this particular topic. Beyond that, if you ask me that why I am interested, like I did my PhD on vehicular communication. So the first reason for choosing this is that we are having research grants available. We are doing our PhDs on this particular topic, and it started long back in 2000. I'll come to the the history of this vehicular communication. And in the past few years, if you'll see that most of the innovations in cars are related to electronics, and basically they are software based. The previous cars and the new cars, if you compare these cars, you will find a lot of changes. Like my car, it is now recognizing my voice. It can play music on my voice, and I can connect my mobile phone to the car. So these are the features which comes now inbuilt with the cars, and it depends on you that how much money you are investing. There are a lot of companies, they are offering a lot of things with the new technologies. And now the best part of this vehicular communication is we are moving towards active safety. Active safety means we are trying to reduce casualties, we are trying to reduce accidents, we are trying to reduce injuries during our transport, while on road or while driving. So during my presentation, these are some of the points that will be considered. Maybe if I'm left with some of the points, I will try to cover, maybe if there will be any slot available later on. As of now, I'm assuming that I will be available for 1 hour 30 minutes continuously. I'll be discussing all the points. The thing that I would like to add in my presentation is that you should be aware of the, the things that are happening in our country. In most of the presentations, I have seen that we usually refer, the standards which are, available in European Union or US standards or Japan. But are we bothering what is actually happening in our nation? So I'll take you to to some of the places which are in India, and they are basically related to standards and regulations. So what are those organizations? I'll try to take you to that particular location. Uh, as far as VENETS is concerned, so VENET means the modern vehicle, which is now equipped with number of things like it is equipped with sensors, it is equipped with actuators, right? If I want to make my transportation intelligent, so what are the things that will be needed? One will be onboard unit. Onboard unit is available in the car. There will be a communication device which is placed on the road. We call it roadside unit. If two cars wants to communicate, they can communicate. We call it V2V communication. If vehicle wants to communicate to the infrastructure, it will be called as V2I communication, right? Now, if you can see this particular car, there are a number of things which are available. Like as of now, all smart vehicles are having their GPS system. Now, every car coming nowadays, they have their, you know, computing platform. They have their human machine interface. So the computing platform usually supervises protocol execution, including those which are very, very important for the security, right? The communication facility that supports wireless data exchange within the vehicles or within the, with the vehicle and the roadside unit, it is taken care by the communication facility support. Hello, Vishwanathji, is it audible?
Yes, sir. Yes, sir. Audible, sir.
There is a power cut at my place. There is a power cut. Okay.
Yes, sir. Yes, sir.
So, yeah.
And I also request to all the participants, please switch off your mic. Actually, there is a humming sound like WhatsApp is on in someone's.
Okay. So it will be very nice of you, very kind of you, if you can put off your mic, please. Thank you.
Yes, sir.
So I was just discussing about the conventional VANETs, like due to the uh, to reduce my, because I've now connected to my mobile. So in order to reduce my bandwidth, I'm just putting off my camera, right? So once the light will be available, the electricity will be available, and I will be available on land, then I can put on my camera. So due to the significant research and technology advancements in the wireless communication. So, okay. So, okay. Due to the significant research and technology advancement in wireless communication, the traditional intelligent transportation system, it has evolved towards the vehicular communication. Now, as I was discussing, the concept of vehicle to vehicle and vehicle to roadside unit communication, they came into existence in research and development as another communication network, and this is what we are called as vehicular ad hoc networks. This vehicular ad hoc networks, it enables communication among on-road vehicles with and it may be without the help of any pre-established infrastructure alongside roads or moving on roads. So a number of state-of-the-art equipment related to new generation wireless access technology. I'm adding this word. There, it can be anything like we can use LTE for communication. We can use WiMAX. So there can be any wireless access technology which is incorporated with the vehicles. Now, uh, with this, there can be equipments which may include display screen, it may have sensor, it can have antenna, camera, radar. As you can see in the, there are two radars available, forward radar and rear radar, then GPS, then receiver, OBU, this is onboard unit, and so on, right? So with this OBU, uh, vehicles enables vehicular communication for enhancing safety, and we use certain things for comfort and affordability. Like when we'll move forward, I will be discussing the heterogeneous vehicular network. So that will help you to understand that how it will be connected. The entire environment is connected. Now, the communication architecture of VNets can be divided into, it can be divided into uh, three categories, including the WAVE, which is also known as wireless access in vehicular environment. You might have heard of the standard IEEE 802.11p. So WAVE is also known as IEEE 802.11p, which is based Wi-Fi. It can be ad hoc, it can be hybrid. So in WAVE-based Wi-Fi driven architecture, roadside units alongside roads are used as wireless access points, which provide communication coverage to the vehicles inside its coverage area. Whereas in ad hoc architecture, group of on-site vehicles forms ad hoc networks using WAVE. These networks will perform operations independently without any infrastructure support. However, in hybrid architecture, cellular and ad hoc architectures both, they use a wave, which is wireless access in vehicular environment, perform their operations in collaborations. So this is some of the scenarios, like if there is a accident somewhere in the road, which can be called as an emergency event. So that event can be notified to the car which is available close to that particular event, and this car may communicate to other cars going to in the other direction, or it can inform to the nearby roadside base station, or we call it RSU, roadside unit. So this vehicle to roadside communication will be again sent to the server. It will be sent to the positions or the centers like hospitals, so that the help can reach as early as possible. Like you can see police van is there, it can be informed to that, ambulance may be informed, or if there is a need of fire station, then you may ask them to provide the facility, right? I would like to tell you some key facts. These key facts are something related to accidents. Like if we discuss number of deaths each year, although this is a fact, somewhere taken from old data. Like if you can see the comparison between deaths due to various diseases, malaria, tuberculosis, AIDS, and road traffic. So it was identified that nearly 1.3 million deaths are only due to road traffic. We'll come to some more facts. See, I'll also try to tell you some facts which are very, very new. Do not think that I've taken just one. I would like to compare, see the number of cars available in 2008 and if we are in 2021, so there will be a huge difference. I will show you the even the sale of cars, how drastically, how exponentially the growth has taken in past so many years. Due to number of cars, we come across traffic jams that generate a tremendous waste of time and of fuel. And most of these problems can be solved by providing appropriate information to the driver or to the vehicle by diverting the route if it is pre-informed that there could be a possibility of traffic jam, right? So we can save a lot of time, we can save a lot of fuel because of this information. Now I would like to consider some other applications where we can put our VNets as applicable. Like you are now familiar that the safety is the prior thing that we are trying to get it from VNets. Then another part is traffic management, driver comfort, or maintenance, like how driver will be having the convenience. Like if I drive a car, I'm going to a new city and I do not know or I'm not aware of the parking space where that parking space is available. As of now, we are totally dependent on Google Maps, or now Google tells everything. So if there is no internet, then will it be possible to work on it? So the new upcoming researches will help you to identify locations for parking, for hospitals, for hotels. Like if you go on to some new places, so which hotel is good, which hotel is close to your requirement. So all these applications will be considered. So if we talk about e-safety, so what are the things that will be taken care? Like this, the first problem, which is also known as traffic signal violation. So a warning will be generated if we violate traffic signal. As of now, there is no such facilities available, although it is implemented somewhere in metropolitan cities. And now traffic lights are being executed in most of the cities, but not everywhere. So people are not, that much concerned about traffic signal violation. Then if we need to stop somewhere, then the stop sign violation. If we are not stopping, then the warning will be generated. General in-vehicle signages, it will be considered. If you are going to park your car, then that signage is important. Then if any emergency vehicle is approaching, then that warning will be generated. Some crash has happened somewhere, then you should be aware. If 10 to 15 minutes prior to that crash, if you are aware there may be traffic jams because of that crash. We belongs to hills, so we have a lot of problems. Like every year we met so many disasters, floodings and all, roadblocks. So if that roadblock may be informed prior to some hours, we can change our plan. Otherwise, you might have heard in the newspapers that a traffic jam for 8 hours, 9 hours close to Badrinath, where the Dr. Vishwanath is running the show. It's not that easy that he's he takes so much pain organizing so many conferences and workshop at a place where nothing is clear. So it's not that easy. So I just appreciate him. Then work zone warning, if some work is being done, roads are maintained, a lot of jams or things are going on. So it should be informed in prior to the passengers, to the drivers, that if an alternate route can be chosen, that will help a lot. Then if one condition was pre-crash, something has happened and you are aware of it, but if you are not aware of it, now come to post crash, what will happen? So how you can approach for help, how if you need a doctor, you should call to the hospital. If you need police care, it must be informed to the police station, or anything, whatever it is needed. So that warning will be generated. Slowly, the things will be updated, right? And whatever event has happened, it usually event data recording is usually done in aeroplanes. You might have seen in my previous slide that there was a plane available, so that event data recording was available over there. Then these all these points are very practical, like wrong way driver warning. If we go to a wrong way, so a warning can be generated. And how steep is the curve, that and what should be the speed, might because we are in hills. So usually people are from outside, those who visit for the first time, they are not aware of the speed limit. So basically there are signages available all around in Uttarakhand that you should maintain speed. If you violate that rule, there is a possibility of something mishappening. So what speed should be taken care? So all these the measures will be come under e-safety. Uh, if we talk about traffic management applications, uh, you might have seen all these points in your nearby, uh, red light uh, points, that if highway is merging, so how to merge with the highway. So there will be assistance. Is it clear? Because what people do is they merge with the highway without looking left or right. So now the sensors are available, which are inbuilt in the car. They will sense, is there any car coming from, or how far is the car? Will it be easy for you to merge into highway within that time zone? So, or you need to pause for some particular time. So what will be that time? That indications, that assistance will be available to the drivers. Everybody is now familiar with the second point, which is electronic toll payment. FASTags are available in India. NHAI has executed almost everywhere. Now, if you rush into FASTag line where cash is not taken, you will be charged double. So please aware of it. And it is now getting mandatory to have your FASTag placed on in your car. Then how intelligently the traffic will flow, that is to be taken care. Then fleet management, it is usually generally for the people who in the VIP category, right? So we cannot, we cannot hold the traffic for long. If it is, if it is, uh, you know, for long, then there could be a traffic problem. Then any vehicle carrying hazardous materials, so it should be tracked. It should be tracked on time and without any so that it cannot harm or it cannot lead to a severe consequences. Uh, this the next point, which is road surface conditions. You might have seen the bad road conditions. Bad road conditions may be identified by the vehicles. It may be identified by the vehicles, and it should be informed to the concerned. It should be informed to the concerned that the road conditions are not good. And based on that, it must be improved on time, because we usually face these problems, because the road situations finally causing a lot of damage to the cars. And it is it is a burden on the customer, on the user, or the owner of the car. uh, Next, we need data which is related to crash, that what are the zones which are very very dangerous. So crash data will help you to you know prohibit or to prevent such situations uh, not to occur in future. Then this rental car processing is also very very now popular in cities like Goa, even Delhi. So how can we track whether the it will not be stolen? It is it is being used by the authentic person. So all these things will be covered in traffic management applications. Uh, Next, if we move towards the driver comfort, uh, we talk about a lot of things like I already covered some of the points, so I don't want to repeat all those things, like parking spot locator, mapping is there, then instant messaging is there between the vehicles, then internet service, or which is related to fueling, which is the nearest fueling station available. Then if your car needs a repair, then how it can be done without delaying it or without much complexities. So it is important for every driver, because every day a lot of people are facing a lot of problems because of all these issues. Right. Starting in the previous one, I was discussing of year 2008. Now we move towards 2016. So this is the data which was taken or updated last on April 2018. So you can see every year the casualties, it is destroying somebody's family. So it is very, very important. It is not only somebody's family, it is uh, doing a lot of things. It is doing a lot of damages to the GDP also. An accident is contributing in GDP. Can we imagine that? So uh, when we come towards the model at the end, there is a business model available. You will understand that accident is, is affecting so many factors. So uh, it has to be understood that this is a very severe problem, and if it is not controlled, that is the only reason why so many companies, even so many governments, they are focusing on this particular issue. Right. So I'm now towards the latest facts. Okay. So the fact says, according to WHO, the total deaths due to traffic accidents on road is 1.25 million per year. This is the latest one. So 1.25 million is a big amount. It's a big data. So you can see people are losing their life. And if we talk about per day deaths, it crosses 32,000. Again, it is a big data. Now, if we talk about the age group between 15 to 29, we call them, youngsters. Think of the parents. If they lost their children in the road accident, what could be the impact? What could be the mental situation? So it has to be, it is impacting that much. Now, as I was discussing, that road crashes are resulting in huge economic cost. And it is 3% of the world's GDP globally. 3%. Only the accidents. Right? Now, as number of vehicles are increasing day by day. So last year in 2020, you might have noticed when the lockdown was executed, it was implemented, air pollution drastically got reduced. That means huge growth of vehicles is resulting in huge air pollution, specifically in the metropolitan cities. So that is why some of the cities like our capital, Delhi, there was a rule implemented by one of the government to pool the car. One day you can drive even numbers car, it means the your number plates. Next day the odd ones to reduce the traffic issues. Now I'm entering to year 2021. This graph indicates the prediction of car sales with some form of connectivity, and it will go on to year 2025, right? So previous year, the number of cars sold was 46.7 million, and now this year it is 52.1. It will keep on growing, and it will go to 81.2 million in 2025. See, it will be almost doubled in next 5 years. If you could see, right now we are having 46.7, and next we will be having 81.2. So you can now easily understand what will be the situation for air pollution, what will be the situation for the accidents. So why all governments are so concerned about the executing intelligence into the cars. I'll come to a point where you are learning IoTs from so many days. So as of now, till this slide, I was only discussing about VANETs. Now, IoT, which is Internet of Things, I'm not going to repeat the basics because you are already, listening to Dr. Vijay Bhaskar Senwal, who is an expert in IoT. So I also attended one of the lectures. So I'm just, coming to the main points. So these are the benefits, like efficiency. What efficiency means? That we will make better use of time. What it will do? It will speed up the process. IoT, when executed with VANETs, will give safety. People will be exposed to less hazardous environments. IoT is contributing towards the society because it is monitoring the health and the social care. So it is that much important. It is helping in, making our environment safe. It is controlling the pollution. It is controlling the air quality. It is helping us in our hills for our flooding alerts. So we have our own system in Dehradun. So the government of Uttarakhand is investing a lot of money. Then IoT will help in productivity, which will identify and eliminate errors which are related to process. So that way the productivity will be improved, it will be enhanced. If productivity will be enhanced, then definitely profitability will be better, because it will be helping us in cost saving, and it will be helping in increasing the productivity, which definitely increase the profitability. Further, it leads to innovation. New products are coming each day. You are seeing that new versions of mobile phones, they are coming, and everybody eagerly waiting for a new mobile. What are the new features? So IoT is leading us towards innovation, new services, new opportunities, new markets. Then it is very, very mandatory that there should be a compliance. What does it mean? It simply means that there should be a way which is new and more effective to monitor and report compliance requirements, so that it should not go beyond the threshold value. because if we do not bother about the compliance, then we suffer. So in order to restrict ourselves, it is very important that we should follow the compliance. You might have seen, you might be doing it everywhere, business intelligence, everywhere, you like Amazon, you might have done shopping or Paytm. They are doing it with the help of IoT. They are executing business intelligence because we are allowing them to gather data based on our requirement, our choice, what we feel about a product, and what could be a different product that could be attached or that could be added with a product. Like if you go anywhere, and you might have seen that where to place a particular product so that if customer is purchasing something, he will definitely purchase the another thing. So this is some sort of decision making ability is uh, executed with the system. So this is how IoT is helping us. So now this IoT is doing wonders. What it is doing? IoT is smartly changing various existing research areas into new themes, including smart health, smart home, smart industry, and smart transport. Now, relying on the basis of smart transport, our topic, this Internet of Vehicles, is evolving as a new theme of research and development from Venice, right? So I'm not going to consider other things. I will be talking about your smart transport. That means now implementing IoT with Venice is helping to have smart transportation. As I told you earlier, there was some 2 or 3 types of communication. V2V, which is vehicular to vehicular, means vehicle to vehicle. Vehicle can communicate with the vehicle. Then vehicle can communicate with the roadside units, which we call V2I, or vehicle to infrastructure. Then vehicle V2R, V2P, and V2S. These three will more be added to the communication. What will they say? Now, this will be the realization, right? This will be the realization. What it will say? It will say that we are going to use certain technologies, and these technologies will be wireless access technologies. Based on wireless access technologies, you can have number of things. Like if we talk about some research and development areas in US, now security chip is being installed in each online devices, including vehicles, to define identity for every entity in internet. In Delhi, all registered autos, electronic vehicles, government buses, and metro rails, they are equipped with GPS and wireless fidelity Wi-Fi, but what we call Wi-Fi. If we talk about European Commission, they has taken number of initiatives for development of next generation cooperative intelligent transportation system. And various reports, they suggest that there is a positive thinking about the connected vehicles in countries like UK, Australia. You might be, knowing it that Google is working with leading automobiles and IT companies for developing Android system for connected drive under the consortium Open Automobile Alliance. Even Apple has developed a system called CarPlay, which enables driver to use all the services of iPhones through the display of car with voice support feature. All the aforementioned efforts are the steps towards the design and development of Internet of Vehicles. Now, earlier there were only three. Now we have five types of vehicular communication: V2V, V2R, which is V2I, V2P means P means they are related to personal devices, and V2S means related to sensors. Each communication of IOB is enabled using a different wireless access technology. Like if I say roadside unit, it could be something else. If I say V2I, it is connected to mobile units or mobile networks. So it can be wireless access technology includes anything like wave. Wave means IEEE 802.11p. It is specifically for V2B and V2R. Wi-Fi and what we call 4G, like mobile networks, or LTE, they are for vehicle to infrastructure. Then CarPlay or NCF, they are using vehicle to personal devices, and Wi-Fi for sensors also. The communication architecture not only includes vehicles and roadside units, but also other communication devices. And the inclusion of a range of devices makes the architecture more complex, but it will be market oriented. When we were discussing VANETs was not market oriented. So since there are so many technologies, we have Wave, we have Wi-Fi, we have mobile networks, we have our CarPlay, Ethernet. So because there are so many wireless access technologies, this makes our network a heterogeneous vehicular network. And we need a framework for this Internet of Vehicles to deal with this heterogeneous vehicular network. And this Internet of Vehicle has what we can say is has a significant potential to guide and supervise vehicles. It has the ability to provide reliable communication, platform for abundant mobile internet and multimedia related applications. So like you can easily see, so this is a heterogeneous. We have a smart car, we have so many technologies available. So it is indicating the your realization of IOB. So if we want to execute it, then how this will be implemented in the vehicles, let us proceed towards that. So we have split our architecture into 5 layers. The layered architecture design of a universal network, which includes heterogeneous networks. It is quite challenging. So basically, it requires to identify and effectively group similar functionalities and representative elements of heterogeneous networks as a layer. So optimizing the number of layers and enhancing the differentiability among layers, it is the significant priority of the layered architecture. So along with the layering of functionalities and representative elements, various network characteristics of the heterogeneous architectures are considered. The network characteristics include interoperability, scalability, reliability, modularity. So these are the some of the points which are very important, and these characteristics needs to be considered. Now, the architecture of IOB, it should be able to interconnect vehicles to devices also, and to heterogeneous networks also. So an open and flexible layered architecture in terms of technology adaptation is more suitable. So some of the key objectives of the architecture design of IOB would be strong integration with internet, which is the basic requirement. Then we should have service oriented architecture, and more importantly, it should be plug and play based interface. It should not be complex. And now many of the things are already executed. So if you talk about this 5-layer architecture, it includes perception, coordination, artificial intelligence, application, and business layer. And the representation and functionalities are written next to it. So let's begin with the perception layer, which is the first layer from the bottom, and is represented by the different types of sensors and actuators which are attached to vehicles, which are attached to RSUs, smartphones, and other personal devices. So, and they are considered in a framework. If we talk about the primary responsibility of this particular layer, it would be to gather information regarding vehicle, regarding traffic environment, and regarding devices which are connected to it. And what information it would be having? It will be having information which may include speed of the vehicle, direction, acceleration, position, engine condition, or it can have travel documents which is related to vehicle. It can have data related to on-road vehicle density, what can be the weather conditions related to traffic environment, and it can have something which can be related to multimedia or infotainment records as per the choice of the people. This layer is also responsible for the electromagnetic transformation and secure transmission of perceived data to the coordination layer. The major issues of the layer are the collection and differentiation of captured information in efficient manner in terms of cost and energy. Moving on to the second layer, which is the coordination layer. It is represented by a virtual universal network coordination module for heterogeneous networks, which includes wave, Wi-Fi, your mobile networks. It may also have satellite networks through which the perceived information from the lower layer is securely transferred to the artificial intelligence layer, which is just next to it, and it is needed. It is transferred to artificial intelligence layer for processing. Now, due to the lack of standards, interoperability, and cooperation among different types of networks, this is one of the main concern in IOB for providing um, reliable network connectivity handled by this layer. The prime responsibility of this layer is to process the different structures of information received from heterogeneous networks and reassemble into unified structure, which can be identified and processed in each candidate network. Moving on to the third layer, the artificial network layer, which is represented by the virtual cloud infrastructure. It is very, very important to understand that cloud plays a very important role here. I will be coming to this cloud computing part, and in the next slide, you will be able to understand that how it is being executed, why the cloud is the best environment for this architecture, right? So we can easily say that this is the brain of IOB. It is the brain of IOB and responsible for storing, processing, and analyzing the information which is received from lower layer and decision making based on the critical analysis. It works as a information management center where computing and analysis technologies or techniques, including regular cloud computing and big data analysis and expert systems, are major operational components. Due to the number of services which are offered in cloud environment, service management is also one of the major concern in IOB. Why? Because exclusive and dedicated services are the requirement of smart applications, which are also handled by this layer. Now the fourth layer of the architecture, which is the application layer. It is represented by smart applications ranging from traffic safety and efficiency to multimedia based infotainment, and it can be also web based utility applications. This particular layer is responsible to provide smart services to end users, which are based on intelligent and critical analysis of processed information by the AI layer. If you remember that this application layer was also envisioned in VNet architectures because safety and efficiency applications were main focus, and smart applications were there for commercial purposes. There is a paper, I wrote it in 2012, Applications of VNets, Past, Present, and Future. Just refer to that paper. You can Google it. And I have mentioned almost each and every point related to it. So now, efficient discovery of services which are provided by this AI layer for combining the smart applications for end users is one of the major responsibilities of the layer. And it also provides end user applications usage data to the business layer. Due to the realization of number of smart applications, the framework of IOB is being evolved as a global network for reliable vehicular communication. Therefore, these smart applications of the layer are thus the driving force for the efforts being made in research and development in Internet of Vehicles. Last one is the business model or the business layer. You can see you will sooner or later you will be coming across this business model. Why I'm calling it model? Because many companies has already adopted this IoT. Like you are familiar with the concept, like every vehicle needs to be insured, every passengers needs to be insured, and there are some fake accidents where people usually grab money from the insurance companies. So in the coming years, the insurance will be intelligent enough where it can be identified what was the situation of the driver when he was driving the car. Was it the fault of the driver, or did he break any, or overlooked or violated any rule? Is he really the person whom the uh, money be given or not? So all the things will be investigated. All the things will be investigated, right? So sooner or later, you will be having all these sort of things. So this fifth layer, it is represented by operational management module. And the major responsibility of this layer is to foresight strategies for the development of business models. Different types of analysis tools like graphs is there, flowcharts is there, comparison tables are there. We can make use of use case diagrams, etc. for the major part of the layer. And we can also think of other responsibilities which may include decision making related to economic investment, like I already told you one of the example. Then usage of resources, pricing of usage of applications, overall budget preparation for operation and management, and it can also be related to aggregate data management, right? Based on this, let's divide our architecture or assume it in the form of a protocol stack. You can see that this protocol stack is designed by efficiently organizing the appropriate existing protocol at dedicated one of the 5 layers which we were discussing. So the aim is to accomplish the functional requirements of each layer identified in the architecture. Now various protocols are utilized, and these are the projects, like if you can see CALM project, C2C, these are all projects by various organizations or various nations. So you can Google them, you will find that there are a number of projects available. Now this protocol stack, if you can see vertically, the protocol stack has 3 planes, including security, operation, and management, right? Then the appropriate protocols are identified for different layers and planes of the architecture of IOB by quite efficiently managing the most of the functional requirements using existing protocols. So I'll go one by one vertically, considering security plane for the first time, then we'll move on to others. So in the security plane, security protocols, which may be, IEEE 1609.2 is there. Then we have Security Information Connector, SIC, it is written there, SIC. SIC is Security Information Connector. Then we can have Security Management Information Base, which is MIB. And we can have HSM. HSM is Hardware Security Module, which could be utilized which have been developed under WAVE, Car-to-Car Consortium, and other projects respectively. Security protocols for IOB is still, an open research challenge. Why? Due to the unavailability of clear definitions of layer-wise security. So you can, those who are very interested to do their research or write their thesis in security, they can choose this topic. Considering the second plane, which is operation plane. So you might notice that in perception layer, a number of wireless access protocols were considered in physical layer, including, as I told you, 802.11p of wave. Then there are some other wireless local area network protocols like 802.11a, B, G. So similarly, wave, Ethernet, 4G, LTE, GSM, satellite communication. Now, the coordination layer was divided into three sublayers: lower, middle, and upper layer. And different MAC protocols could be utilized at lower sublayer, including 802.11p, 802.11a, b, g, n, and 1609.4, along with the global handoff manager. The design of global handoff manager is again another open research challenge in IOV. You can consider and you can Google it, that you will find a lot of things available. Okay, so this IOV is considering range of technologies at perception layer. So whereas LLC protocol could be considered at middle sublayer, and at upper sublayer, three protocols including C2C, which is a network protocol, then short message protocol, WSMP, and we can have fast application and communication enabler, which could be considered for carrying out the operations of network and transport layer apart from traditional IP. And there could be a combination of UDP and TCP, right? So it will make your communication reliable or unreliable based on your choice. So these protocols are suggested by various projects as network layer protocols. And it can be easily understood if you are familiar with the TCP/IP protocol. So, right? Now, in the artificial intelligence layer, the CALM service layer and the wave 1609.6, which was service related protocols, they could be considered at the lower sublayer. Then VCC, which I was discussing, vehicular cloud computing or big data analysis related to protocols, could be utilized at the upper sublayer, including the cloud services, storage as a service, or infrastructure as a service, or network as a service, or you may have cooperation as a service, or maybe entertainment as a service. You can have gateway as a service, you can have picture as a service, or computing as a service. So all the protocols for AI layer are open research challenges in IOV due to the unavailability of suitable protocol for regular cloud computing and big data analysis. Right now, then we had the application layer that includes two sets of applications. One is called Smart Society and Efficiency, written as SSE, and the another one is SBO. SBO is Smart Business Oriented. So these are the two applications. And on the top of these applications, we have one resource handler protocol 1609.1, which is also defined in vehicular access for regular environment, wave. And it could be utilized for managing resources among smart applications. Coming on to business layer, four types of business models, including INS. As I was discussing, it was for insurance. Another is SAL. SAL is for sale. Next is SER. This is for service. ADB, this is for advertisements. These four services are considered. These are the four business models which can be considered in the business layer. Again, as I was discussing, these are also open research challenges. So people are doing a lot of research in all these topics. So now the success of IOB, it highly depends on the effective and efficient development of these business models, which are the most significant for the commercialization of IOB, which was missing in Venice. Now, coming to the last plane, which is the management plane. In this plane, three protocol groups belonging to the management operations in Wave, CALM, and CTC could be considered. Layer manager, which is IEEE 1609.5, and channel coordinator protocols are developed and suggested three protocol for management purposes. One is application, another is network, and the third one is interface managers. So information connector protocol has been suggested for C2C purpose, right? So this is all about the protocol stack of IOB. Coming on to the network model, how it look like. As I told you that we'll be considering cloud, right? So Internet of Vehicles means the combination of cloud, connection, and client. These three major network elements are identified. We'll come on to the logical view based on these three elements. It will look like this. Now, the first element, if you see, the first element is cloud, right? So this cloud is representing the brain of IOB. A range of services related to intelligent computing and processing are offered as primary cloud services. These services are offered on cloud platform provided by cloud infrastructure. The cloud-based intelligent computing and processing services are assessed using a reliable connection, which is the second element of IOB. A range of wireless access technologies I have already discussed multiple times can be utilized to establish a connection. The different types of regular communications of IOB represents a different connection due to the usage of different wireless access technologies. Now, due to the different types of connections, but smart client applications, which is the third element of IOB, each client application has service requirements, which might be different from other clients. The service requirements of a clients are defined in terms of characteristics of wireless access technology. Therefore, prioritized preference of wireless access technologies are used by client applications. So the magnitude of traffic related information would enlarge drastically with the realization of IOB. This is due to the integration of different types of networks. A smart intelligent transportation system of a city for dynamically collecting, processing, and disseminating real-time information. For an example, if you talk about metropolitan cities like capital of India, Delhi. So what will be the requirement? It would require information processing system of petabyte scale. So for handling information of this magnitude, cloud computing framework is the best environment. A framework to highlight the role of cloud computing as an element of IOB by utilizing the concept of cloud based on application servers. Uh, the framework has three major operation levels. It is something like this, like basic cloud services. Then we can have smart application servers. We can have information consumers and producers. So the operation levels are based on cloud, where traffic information is uploaded, processed, stored, and disseminated using cloud architecture. Basic cloud services are the core operation framework for realizing cloud-based smart ITS application servers. And the three operation levels are being shown in the figure. Let's talk about the basic cloud service, which is offered to smart traffic application servers, including cooperation as a service, CAAS, and storage as a service, gateway as a service, computing as a service, or network as a service, data as a service. So smart intelligent transportation system application servers are considered to be developed and deployed on a cloud platform which provides basic cloud services to the applications for Internet of Vehicles. So how this smart ITS application servers are divided? So they are divided into four categories. One for traffic safety, another for traffic management service subscription, and one entertainment. Two processing engines, namely internal and external engines, are considered for smart servers. The internal engine includes big data unit, processing unit for big data and analysis, and all the operations of these three units are performed using the basic cloud services offered at cloud platform. The external engines, they include information dissemination unit, which is responsible for end-to-end delivery of services to client applications, and information collection unit responsible for in-source data gathering. Coming to the third part, which is information consumer and producer. So if you talk about smart devices of IOB, which includes vehicles, personal devices, and RSUs. So they are the end users of the intelligent information, which is provided by the smart servers. These devices are responsible for data gathering from, let it be vehicular traffic environment, and the development of business models for the organizations related to insurance, automobile productions and repair, and other internet-based services is also one of the, maybe considered as the major usage of the data gathered by smart devices. Now the services offered by the smart application servers may be something like smart safety, smart traffic management, smart entertainment, and it can be smart subscription for basis of smartness in Internet of Vehicles. The primary responsibility of the cloud servers is to process and apply artificial intelligence and in real time big traffic data to make intelligent decisions for smart client applications. It would require a real-time operating system for the activation of IOV services, and Google is already involved in it. They have already, developed a Android-based real-time operating system for IOV with the help of Open Automobile Alliance, right? So this is the first part. Now, the second part, which was the connection, right? This connection is utilized to establish and maintain the communication between the cloud and the vehicles for assessing the cloud-based smart services in IOV. And it has already been told that there are different types of networks. So this is, interconnection among these networks is significantly challenging. So there are two major components of connections. The one is TPNIO, this one. The first one is TPNIO. This is third party network interoperator, and GIN, which is gateway of internet working. This TPNIO is responsible for management of the connection, whereas this GIN, it represents the connection, right? And both of these components and prioritize the preference of wireless access technologies for connections will be, very, very important. Like the need of direct service level agreement, which we call SLA. Those who are, related to internet services, they are very much aware of these service level agreements. It is always done between the operators of the networks. It is reduced in IOB due to the consideration of this TPNIO. The direct SLA is a challenging constraint for any heterogeneous network. TPNIO, it establishes seamless roaming without compromising the quality and security of the services of network operators. There are 5 components for this TPNIO, which is GHM. This is Global Handoff Manager. Then we have Global Authentication, Authorization and Billing, GAAP. We have Service Management, and next is Network Database, which is NDB, and Operator Database, ODB, right? This Global Handoff Manager, it is responsible for performing seamless transfer of ongoing communications between any pair of operators of the networks in IOB. And it is a global handoff manager and can perform handoff between a pair of operators of different types of networks in IOB. Development of global handoff manager is really challenging, and it has been adopted as a research challenges by many academicians for heterogeneous networks, right? So talking about the second components of this TPNIO, which is Global Authentication, Authorization and Billing. It is responsible for verifying vehicles' credentials and granting permissions to access network services. The usage-based pricing is important of all the network services, and all these are handled by this Global Authentication, Authorization and Billing. Those who teach wireless networks in BTech, they are quite familiar with this protocol, right? So the operations of Global Authentication, Authorization and Billing is quite complex and challenging. considering the fact that vehicles might belong to the operators of different types of networks, like we have roaming in mobile networks. Therefore, the idea of third party is considered as a TPN IO, which has this gap in the verification and pricing. Talking about the third component, which is service management, which is responsible for providing and monitoring quality of services offered to vehicles. It uses service quality agreement between operators of different networks. It helps to deliver guaranteed services to vehicles using service quality agreement, maintaining service quality between different types of networks, which requires consistent observation. The concept of service quality rating may be utilized for the quality management. Now moving on to the next component, which is network database. And it is a database of the registered networks with their technologies and protocols. And this database is utilized to identify network while establishing a communication between the operators of different types of networks. And moving on to the last one, second last one, the ODB. This is also a database of the registered operators of the different types of networks. And these operators have SLAs with the TPNIO, due to which the need for direct SLA between operators is not required. And the database is utilized to identify operators and their SLAs to provide guaranteed quality of service. Right? So these were the 5 components of TPNIO. Moving on to the second one, which was Gateway of Internet Working, GIN. So as we are into heterogeneous networks, and we are using different wireless access technologies, as I discussed, V2V, V2R, V2I, V2P, V2S. So the vehicular networks are represented by different wireless access technologies, right? The V2I, it is already, it will be repetitive. So these networks are using or representing a kind of technology. So they are utilized by the client applications to access the services of smart-based servers with the help of gateway of internet working. Each vehicular network has its GIN, which coordinates with the TPNIO to establish and maintain a connection. There are 3 components of GIN. One is mobility management, MM. Second one is local authentication, authorization and billing. And third one is traffic management, right? So you can easily see all these things. So I have covered this network model of IOB. I would like to take you to the importance of this is already covered. Some of the part is already covered. So because we are moving towards the lunch, so let me show you something which is very, very important. How this advancement and development was done starting from or we can say in the last 20 years. So the inception of VANET or the concept of VANET was developed based on the concept of MANETs in the year 2000, where VANETs were considered as an application of MANETs, right? And I was, I did my master's on, data scheduling that time. So the key research areas were including MAC and routing protocols, so design, mobility models, Like there was a like as of now you have NS2 and S3, so there was a platform available. We call it NSUNS. Now it has been commercialized and it is now renamed as STNet. So we executed our implementation on NSTUNS. So simulators were designed at that particular moment of time. So that was the advancement. Then it took until 2006, 7, 8. Then it started with the development of certain protocols, including 802.11p and family of IEEE 1609. They were developed, and there were a number of projects in Europe, Japan, Korea to develop similar standards for WEDs. Then scalability, commercialization issues of vehicular communications through heterogeneous networking were explored as a step of early concept development of IOB. Now IOB has been, incepted, and we are moving towards the other issues in IOB and other issues related to standardization, like effective and efficient integration of existing standard of different types of network as a standard for IOB. They will be explored. I discussed number of open researches which are going on, and we are executing artificial intelligence, we are executing big data analysis in IOB. All the complexities related to all these technologies will be investigated. Now it is up to you which technology you use to overcome or to simplify the situations or the problems, right? Moving on to some other things. So this is all about the, as of now, I have covered almost, layered architecture, network model, challenges, and what are the future aspects. As I told, there are, if you can please bear with me for 2-3 minutes more, I will be very happy. Like in India, uh, those who are doing their research on vehicular ad hoc networks or IOB, it will be helpful to them. You can reach out to this particular report. Every year, Ministry of Road Transports and Highways, they give their reports. You will find that they are, very, very interesting. So quote or, refer these reports. So road safety in India, this is the latest report, which was developed by Indian Institute of Technology in May 2020. It's very early, the last year report, right? So you can visit these websites. So I will be quickly, closing it. Don't worry. I can understand you will be waiting for your lunch. So you please visit these websites. They are very, very interesting websites. I have just taken the screenshot. Okay. So everything is already, covered. So this is the data which is taken. So you just I begin with this particular uh, link, which we call decade of action. So this is the plan. It started in May 2011. Now it has been, all the points were covered. It is very, very important, right? So okay. So in India, ARAI is the organization which is the research institute of the automotive industry that works with the Ministry of Heavy Industries, Government of India. See, it was developed long back in 1966, and all the centers which are available are in Pune itself. A lot of things are available. Just go and visit ARI website. You will find a lot of things. A lot of information is available. Then you will, all sort of research is carried out over there, right? With this, I am closing my presentation. And if you have any queries, so there was, a lot of things related to security and all. And if you have any queries, then it's fine. If no, then very nice. I will be free. Over to you, Dr. Vishwanath. Thank you so much.